Hello everyone, I hope everyone is doing good. So this is a continuation to the previous video. So in the previous video we saw about the embedding, what is the meaning of embedding, why we create an embedding, what is vector embedding, and how it helps in the semantic search or the semantic meaning of the overall sentences or the paragraph. So in this video, we are going to look into practical aspects. We'll look into how we create an embedding, how we visualize the embedding, what are the required libraries are needed, from where you will get the sample data set, and how to interpret this visualize. So we'll start with this Google Colab. So you can create your ID. If you have a Gmail account, you can directly go and log in into the Google Colab, and we will mount our Google Drive. So this is my Google Drive content drive. So this will mount my Google Drive. Yes, you need to run this. So in my case, I have recently mounted it, so it will not ask for the authentication and all. In your case, it may ask the authentication to log in into your Google Drive. Like it's again asking. So I'm connecting to the Google Drive here. It will ask for the initial step. It may ask for something more, but later on it will just ask you to authenticate with few clicks. And once it's get authenticated, you will this your Google Colab and this notepad will be able to connect your Google Drive, and from the Google Drive you can pull the data and do all the stuff. Before going into this data import, I want to show you like from where I got this data. So this data is about the food review. I have taken a small sample of the food review data. There were around thousands of lines, and it was very difficult to run the code, run the algorithm on that on the food data. So we have, you can just Google it and you can search like in the Kaggle, you can get the Amazon Fine Food Review. There are multiple food review data set you can get it. So you can download the data from here and it will be mostly in the GIF format. You can unzip and then you can upload that in your Google Drive. So this is my Google Drive. So in my food review, my drive, food review folder, I have uploaded this data. This data, as I mentioned, was a very big data, more than thousands of record. So I have reduced it to around 100 or 200 of records. I have reduced it. So my drive and food review and food underscore apps is the data set. So I'll go into my Google Colab. So I have already mounted my Google Drive. First, I will import few of the necessary libraries from the Python like NumPy and Pandas. For if you're working with the data, this is very much necessary. Now I'm defining the path. This is still my Google Drive, and then my drive, food review, and food apps. Right. So if I run this, okay. So in this cell, my data is equal to, I'm reading this file path. Okay. Now I want to display this data. So you can see in the data, I have multiple columns, date, content, score, username. So I'm concerned about the content, like the review content, what the user has generally given, like being single and traveling a lot, and there must be more thing you can read, look into it. I've had this payment issue, the customer support or message center, overall app service had worked well. So this kind of review, like there is an angry complaint here. What's the point in business if you don't do? So you can expand this and you can look into the data sets. So these are general review of any food delivery apps. So in this we are using this data, and this has around 100 or 200 records will be there. So once you read this data, we have to convert this data into the list. So we have to convert this data into the list, because with this list only you can embed, you can create the embedding of the data. So embedding, what we have learned in our last video. So embedding is the way of representing or converting your data into a numerical format, in a vector format, so that we can visualize in a multi-dimensional ways or multi-dimensional space. So I'm just converting into two list. So you can see, like for example, this being single and traveling a lot of work around the world, I have used a quiet name of delivery apps. I must say, Bolt Food app, Malta is pro. So this is a very long review, all this thing. So this may not give the accurate result out of when we visualize it, but mostly it will try to give you the very near kind of result. So this video, we are not here to judge the output what it is giving. We are trying to understand how we create embedding and how where we visualize and how we visualize it. Right. So I've created I've converted this data set, this content column into two list, because we are concerned about this content column only. Now we need something to create the embedding. For that, we'll use the sentence transformer. This is from the Hugging Face. So in the Hugging Face sentence transformer library, you have multiple model. So if you go into the Hugging Face sentence transformer page, so there will be multiple what do you call models. For example, if I go into this, when you scroll down, you'll see multiple models, like 127 models are there, different data set on which this model has been what you call trained. So if you expand this, these all models are there, and each model has a specific purpose in the NLP. Hugging Face is very good in creating a solution around the NLP. So we will look into a particular model which is very famous and very much used in NLP. So that is all mini LM, and that is the sixth version or V2 version. Let me search that. Okay. So this one I was talking about. So this model we are going to use, you can look into the more detail of it, and there will be where in somewhere you will have the information that on which all data this has been trained. So you can get all the information of this particular model, all mini LM L6V2. Okay, so we are going to use this. So before using this, we have to install the necessary libraries. So we have to install the sentence transformer. So this has already been installed for me. Again, I will just click on this. Now we have to import the sentence transformer library from this particular packages which which we have downloaded. So we'll just click on this. Okay, now this has been imported. Now we have to load this particular model. So I'll just create a variable in which this model name is being passed, and then in the sentence transformer library, I'm just calling this model. Okay, so this also has been done for me. So I will again run this. Okay, so this model is loaded. So now we have to create the embedding out of that content, the reviews content. So reviews was the our data set in which when we have created the list. See, if you see, this one is like the list of the our content. So I'll go into this, and so now we'll create the embedding. So creating the embedding is quite easy, a single line of command. Or like if you see the theory of the embedding, it's very quite complex. So we'll just pass this review into this model, and then if you generate this, so it will create the embedding out of it. And then you have to see what is the content inside the embedding. So these will be array of multiple dimension. Like if you see in a single array, these many content is there inside one element of the array. We have these many content, then we have another these many of content, and each thing inside this array with the dimension, it describes the dimension of that particular sentence or particular review. So if you look into the dimension of this, so I have taken the first array, zeroth array means first array, and the shape of it 384. 384 means 384 points are there in this particular row, and 384 shows the 384 dimension of that particular sentence, particular reviews. Now imagine visualizing or looking into 384 dimension is very complex, and that is not possible from us, like from a human eye or human visualization. We cannot visualize 384 visualization things or 384 dimension thing. So we have to reduce this dimension to visualize the output. So we have libraries in Python. With the help of that libraries, we reduce the number of dimension, and the meaning or that particular point entity, how it interact with the global entity is not being changed much. We just are focusing on reducing the number of dimension. So for this, we have to use UMAP. So UMAP is one of the Python library. So with the help of UMAP, you can reduce a higher dimensional vector thing into a low dimensional. You can pass the number of dimension as a parameter, and with the help of that, you can just reduce the number of dimension. So we have to first install, we have to pip install UMAP learn. So that is already done. Then import UMAP, and then we need to plot that UMAP also. You need to plot that dimension. So for that we are using matplotlib. So we have imported all this thing. Now for plotting into this, So the dimension data which we have got after that, we need to convert it into tensor object. Okay. So what we are doing, we are just look getting the embeddings and just passing into that model again. So now this time we are creating an embedding, and that embedding is converted into a tensor object. So you see the same thing we have used earlier, but we have created the embedding in the form of array, but now we'll create in a form of tensor object. Okay. And when you see the output of this embedding, so I will create first embedding of this. And now when you see this is of a tensor object. Okay. Now we have to reduce the number of dimension. So I'm just passing n component 2. Okay. So it's a two-dimensional thing we are passing, and the reduction matrix or the similarity matrix which we are going to use is cosine. There are multiple similarity matrix, so we are going to use cosine here. So we are creating this with this similarity matrix and number of dimension, and this is being fit into this embedding with the fit transformer. Okay. Okay, I'm getting some issue here. Your map is not defined because I have not run the previous one. Let me run this. Okay. So now this will reduce the dimension into a two-dimensional thing, and then we can see the output here. Let it get run. Okay. So now we'll see the output of this. Now we have only two things, 2 point. We don't have multiple point of 384, which we saw earlier. So the dimension has been reduced. Okay. Now what we have to do, we have to plot it. So I'm just plotting it with the help of matplot. And you can see in the two-dimensional, this has been scattered. It depends on the review. If you have a very distinct review in your data set. So if I would have used the full data of the Kaggle, in that case, I would have seen some clustering being created here. But now it is very much diversified. Like we cannot get the information out of it in a two-dimensional. So what we have to do, we have to create a cluster of the data set, and with that cluster we can visualize, we can understand like how this food review pointers or food reviews are being plotted or being visualized. Okay. So as I mentioned, we need a data set which have a very variety or diversify kind of food review. Then only we can see the cluster very clearly. So we'll create a cluster now. So for creating a cluster, we are using k-means. So cluster is basically combining a similar kind of data into one of the cluster, which is near to it. So this is used in machine learning for the unsupervised learning, in which we combine a similar distance or or close distance object into a single cluster. So we are using k-means clustering here, and we are defining here the number of cluster as 3. That means 0, 1, 2. This 3 cluster will be created in a two-dimensional. And let me import this library, applying the cluster, and with the data set, we'll apply the cluster. And now we'll able to see that. So now this cluster underscore labels contains all the label means cluster number. So for each data set, now this cluster number has been applied to this data set. That means each row will have a particular cluster number that will get it from here. So we already run this. So now I'm going to see this data. Now there will be one extra column here, cluster label. So this particular review is in at one cluster. This is a second cluster. This is a zeroth cluster. So you can see that number is 1 to 0. Means we have defined three clusters, 0, 1, 2. So we will have the range from 0 to 1, and all the records will be given a particular cluster. Now the similar kind of review, similar kind of record will be in a same cluster. Now we have to create the graph of it. So I'll run this one. Okay. And you can see this graph. Now we have three cluster, three different color, yellow, blue and red, and you can hover over this and you can see what's the particular review on that, and depending on the same kind of review will be at the same cluster. So we have used very less number of records, so we don't see a very proper kind of cluster, but you can see that similar kind of records are being clubbed together. Okay. So this is a two-dimensional cluster. Similarly, you can convert into three-dimensional and get a more visualization out of it. I hope this will be useful to you. Yes, go and practice this. Get the data set from the Kaggle and just practice this. If you have any doubt, please post your doubt in the comment. I'll get back to you. Till then, happy learning.